Hi everyone, let's talk about chemical bonds today. So the first thing is, what is chemical bond? Chemical bond is the attractive force which holds the atoms together. Now, why do the elements or compounds are formed through the chemical bonding? Because they want to achieve octet. They want to achieve the octet configuration. Now, what is octet configuration? That is having the stable most electronic configuration in their atom, which means having the configuration of the atoms which are close to the noble gases, such as helium has 2 electrons, neon. If I break it down, we would see that the electronic configuration has 8 electrons in its outermost shell. The same goes for argon, which is another noble gas or inert gas. It has 3s2. It has 8 electrons in its outermost shell. So it is seen that the noble or the inert gas have 8 electrons on their outermost shell, which makes them the most stable elements of all, and that means they do not want to lose the electron or accept electron, stay in their most stable form and all on their own self. This 8 electrons on the outermost shell is called the octet. Now, how do the elements can achieve this octet electronic configuration? Let's have a quick look at that. So usually chemical bonds are formed using either of these 3 techniques. One way is that you can donate electron. Any element when donates electron becomes a positive ion known as cation. For example, sodium, when it gives off or donates 1 electron, it becomes the sodium ion, which is the cation. Now let's talk about what happens when an atom accepts electron. Any element which when accepts electron becomes negative charged, and in case of chlorine, it receives the electron from the sodium atom and becomes a negative charge, which is known as the anion. So in these 2 ways, they can achieve their octet. Besides that, when they don't want to accept or donate electrons, they can do one thing, that is share electron. For example, let's consider hydrogen. It has only 1 electron. So what happens is it can easily share an electron with another hydrogen atom so that it will have a duplet electronic configuration, just like the helium, which is a very stable inert gas. So what does it do? It just shares electron. One hydrogen shares 1 electron with another hydrogen and forms the most stable form of hydrogen, which is H2. So from these 3 things, we can say this is how the chemical bonds are formed. And when it involves accepting or donation of the electrons, then it is called ionic bonds. And when it's all about sharing electron, then it's covalent bond. Now let's get to know about the ionic bond. Okay, now let's talk about ionic bonds. It is very evident from the name that ionic bond is formed through the ions. And now, just like before, here we would see the donation as well as the reception of the electrons. What happens is, I have drawn the electronic configuration over here. From sodium, we see that it has 11 electrons, and this is how the electronic configuration looks. And chlorine, it has an electronic configuration consisting of 17 electrons. And so they want to achieve the octet configuration of the 2 noble gases, which are neon and argon, which are the closest to electronic configuration. So from here you see that sodium has 11 electrons. So the closest electronic configuration of the noble gas is neon, and to have a configuration like neon, it just has to donate 1 electron from its outermost shell, that is this electron. And so what happens is, sodium, when it gets rid of this electron, when any atom gives off electron, it becomes negatively charged, which is called a sodium cation. So since it donates one electron, so single positive, and we call it cation. Okay. Just like that, chlorine, it has a configuration which needs just one more electron to have the closest octet configuration of argon, which has 18 electrons. So this chlorine will accept the electron donated by sodium, and by doing so it becomes a negative charge. Since it accepts one electron, so one negative charge, and this is known as anion. So here, when the bond is formed between a sodium ion and the chlorine ion, then it gives a solid structure, which is a salt, a sodium chloride salt. Usually this ion is obtained in the gaseous form. This ion is also present in the gaseous form, but we get sodium chloride in the solid form. Okay, now if I just want to visually represent easily, so this is how the electronic configuration looks like, and this is a very popular diagram you have in your textbook as well. So this is how the normal stable atom of sodium and chlorine looks like. To achieve the stable configuration like neon and argon, this sodium donates its outermost electron to this chlorine atom, which has just one electron short of the octet configuration, and by doing so they become positive and negative charges, and this reaction between the positive and negative charge is called the ionic bond, and this force of the opposite charges is known as the electrostatic force of attraction. So when there will be any force regarding the charges, if it's opposite charge, then it will be the electrostatic force of attraction, but if it's like the same charge, let's say positive positive, then it would be electrostatic force of repulsion. Okay, so this is all about ionic compound, very easy. Here the atoms, just to get a summary of all of the things I've been saying. So the atoms want to get the stable configuration, the octet configuration, like the noble or the inert gases. In achieving the configuration, they would want to lose electron or donate electron and become a positive ion, and the other party would become a negative ion by accepting the electron, and the bond formed between the opposite charges by the electrostatic force of attraction is called the ionic bond. And is the cation for ionic compounds is always a metal. Here you can see it's sodium, and the anion for ionic bond is always a non-metal. Here it's chlorine. Hope this video helps. Okay, now let's talk about something very important. What should be followed to form the ionic bonds? So in order to form an ionic bond, what conditions should be met? What conditions should the metals and the non-metals, that is the cations and the anions, must maintain in order to form an ionic compound? So valence electron, lattice energy, ionization energy, electron affinity, and electronegativity difference. These are a few conditions that I'll be discussing now. So valence electrons means the outermost shell electrons. So in order to form the ionic bond, the cation or the metal, in the case we use sodium, must have a valence electron of 1, 2, and 3, so that it can easily donate them. And for the anions such as chlorine, it should have valence electron of 5, 6, or 7 in its outermost shell, so that it can quickly grab as many electrons such as 1, 2, or 3 to meet the octet configuration. So that's why this is also one of the ways how you can identify which one in an ionic compound is a cation and the other one is an anion. The cation will always have a very short numbers in their valence electron, and the anions would have bigger numbers. In case of sodium, we just saw sodium had a single electron in its outermost shell, and chlorine on the other hand had 7 electrons on the outermost shell. So in order to meet the octet configuration, the chlorine had to accept the electron donated by the sodium. So this is the first condition. Okay, Now let's talk about the second one, which says lattice energy. So from the properties of ionic bond, we already know that the ionic compounds are always solid and mostly crystalline structure. And we can also think of the salt or the sodium chloride as well. When you take some salt in your hand, you would see that they come out as small crystals. So which is very evident that most of the ionic compounds, in fact all of them, are solid and have a crystalline structure. So in order to be an ionic compound, they must have high lattice energy. Okay, so the second condition is that it must have a very high lattice energy. So we know that they are already crystals. So lattice energy is the energy that is released when 1 mole of the crystal structure is formed from its gaseous condition. So the higher the lattice energy, the easier will be to form the crystalline structure from the gaseous ion. So in order to form the ionic bond, high lattice energy must be present between the cations and the anions who are participating in the bond formation. Okay, the third point is the ionization energy of the metals should be low. Okay, just for the example we used, that is salt, sodium chloride, the metal here was sodium. Now, a very interesting thing is what is ionization energy. We know that the sodium had to release or donate 1 electron from its outermost shell. So ionization energy is actually the energy which is released by the metal in order to donate its outermost shell electron to chlorine. So this energy must be low, because if this energy were high, then sodium would not probably want to donate electron to the chlorine atom. So the ionization energy of the metal or the cation in the ionic bond should always be low. Okay, and then what should be the condition for the chlorine? Because now we have already talked about the energy that is required to be released when 1 electron is removed from its outermost shell. Likewise, for chlorine, the amount of energy that it needs to accept 1 electron is the electron affinity. And from the word itself, it's very evident that how much of affination does the nonmetal have towards accepting the electrons. So the higher the electron affinity of chlorine, or let's say the anions in the ionic compounds, the better will it be for forming the ionic compounds. So for chlorine, they should have a higher affinity or higher electron affinity to accept this electron from the sodium metal. Okay, and the last point is the electronegativity difference. So for any elements forming the ionic bond, the difference of their electronegativity value should be more than 2. And I'll be using the same example, that is sodium and chlorine. And here we know that chlorine has an electronegative value of 3 and sodium has 0.9. So if we see the electronegativity difference, it's 2.1. And we already know that the electronegativity difference must be higher than 2 or greater than 2. So from the calculation, it's evident that since the difference between the electronegative values of chlorine and sodium is 2.1, which is greater than 2, so they are able to form the ionic bond. Okay, now let's talk about the properties of the ionic compounds. Since we already know that every ionic compounds are usually crystals, so it's very obvious and easy to remember that all the ionic compounds are usually solid in physical state. And since they're solid, so obviously their high melting and boiling point would definitely be higher than those in liquid or gaseous condition. So from just using your common sense, you can say, yeah, they are solid, so they have high melting and boiling points. And then they are very stable. Any compounds, when they are in the solid state, they are always stable, more stable than that of the liquid or the gaseous phase. And also, since they have a lattice crystal structure, that means that all of their atoms are present in a small place and in a very dense condition. And that's why, let's say for sodium chloride, if this is a crystal or a cube of sodium chloride salt, so since they're solid and in stable condition, that means that they have a lattice structure, and in the when it says that they're a crystal in a lattice structure, that means that all of their atoms are present in their particular position in the crystal molecule. So let us consider this is a small crystal of sodium chloride. So what happens is that in every single position of this atom, the element, the atoms are present in their particular position. So what happens is that there is a huge number of molecules, or let's say a huge number of the atoms in a small place, and that's why they are very dense. And lastly, since they are hard and they are crystalline structure, they are brittle, which means that they get easily broken. And if I were to say the logical explanation behind it, it's very interesting. We will take the example of sodium chloride again. So what happens in a sodium chloride compound is that the positive sodium and the chlorine are arranged alternatively. So let's say that this is a crystal of sodium chloride salt, and you just apply a small amount of force on it. What happens is the positive charges is getting down and taking the place of the negative charge, and we know that the like charges repel each other. So one positive charge and one positive charge would always repel one another, and that's why they are easily breakable or fragile. That means when pressure is applied, this line of the atoms pushes forward and the positive charge goes behind, or becomes a little bit down, and in doing so the like charges are beside one another. When there are two like charges, they always repel, and that's how the ionic compounds are fragile or brittle. Okay, now this is how we already see the opposite charges of the sodium chloride are arranged one after another, and what happens is that they will only be soluble in the solvents that have charges like them, like water. So when any compound, when any atom have charges, we call them pole. So since the sodium chloride is a polar solute, it will always be soluble in water, which is a polar solvent. Here I have drawn the poles of water. Oxygen in water has a partial negative charge and hydrogen has a partial positive charge. And what happens when this sodium chloride comes near the water? This hydrogen will go and take away one chlorine atom, and this oxygen, which is negative charge, will go and try to dissolve one sodium atom. And this is how the opposite charge help in dissolving the polar solutes in the polar solvents. Okay, last point that we are going to discuss is the ionic compounds. Usually they do not conduct electricity, but when they are present in the solution, that's when they conduct electricity. This is very evident from the word that is electrolytes. Sometimes we go and get some electrolyte drinks. What happens is that you have, that's mostly a saline suspension. For example, when this sodium and chlorine are present in water, that is the same electrolyte drink that you go and get when it's very sweaty in the hot. So if you try and conduct electricity through it, you will see that it's actually conducting electricity only because they are in their ionic form when they are dissolved in the water. This is how the ionic compounds conduct electricity when they are soluble in water but not otherwise.